Welcome to AMS on the Air. I'm Jeff Rosenfeld.
I am Irene Sands.
And I'm Dakota Smith. We're ready to podcast about all things weather, water, and climate.
Sandy really exemplified a lot of the operational and communication challenges associated with these transitioning structures.
What we're doing for tropical cyclones has merit for how we could communicate extratropical cyclone impacts, especially since some of them are similar, such as winds and storm surge.
This week we're featuring an interview that Jeff did with several authors of a two-part article series in AMS's monthly weather review, one of which was just published in the April 2019 edition. The articles talk about extratropical cyclone transitions, both of which are review articles, and they encapsulate pretty much everything we know up to now about the extratropical transition of tropical cyclones. They also dig into the review process for articles that are this big and contain so much. In-depth conversations on articles that cover such important topics is something that we hope to bring to AMS on the Air a little more regularly in the future. It's a lengthy interview, so let's get to it.
Thank you all for being here. It's a special episode for AMS on the Air because of a number of reasons. First of all, we've just started doing more podcasts that we're putting down on tape, so to speak, about papers that are coming out in AMS journals. And this is a double whammy because we're talking about two papers today, two-part review of extratropical transition. And that alone, just having two papers in one makes it sort of fun. And we've got an interesting spin on this as well, because not only do we have the authors or lead authors in this case, we've got Clark Evans from the University of Wisconsin in Milwaukee, and Kim Wood from Mississippi State, and Julia Keller, who wrote as lead author, has just published the second part of this duo, this tandem of papers in the April monthly weather review. And Julia's from the Deutsche Wetterdienst in Offenbach, is that right?
Yes, that's right.
Yeah. Okay.
German Met Service.
Yes, the German Meteorological Service. So we're all across various time zones, but it's great to have you all here together. The other thing that's really cool about this is that we have the chief editor of Monthly Weather Review with us as well. So we can talk a little bit about the inside scoop on the process of these two papers, which I think is really pretty interesting because having two papers as a team like that is already an interesting process in terms of review, I think. But the fact that these are two review papers is doubly interesting for us. So review papers have been traditionally kind of sparse in AMS journals, but Monthly Weather Review in particular has taken the lead in encouraging these kinds of papers. And Dave, maybe you can explain a little bit about what your philosophy is about review papers and why it is that they're so important.
Thanks, Jeff. The review article has actually been a long-standing department within Monthly Weather Review. So, this preceded my tenure, but when I became chief editor in 2008, it was really important for me that we get more of these review articles into the journal and start publishing them. Why that was important to me was because there were several review articles that had been published in Monthly Weather Review in the 80s. One in particular on upper level fronts was very influential for me as a scientist who studies fronts, and was very helpful for studying for general exams for my PhD and so forth. So, as I said, when I became chief editor in 2008, it was really important for me to see more review articles, more well-written review articles that would kind of have this utility that would serve grad students, other people looking for general information. And so I went around and started publicizing that we wanted more review articles. And, when I knew people were working on articles that could be turned into reviews, then, I encouraged them to submit them to Monthly Weather Review. And as a result, we've published quite a few of them, and they've been very highly cited. There was several years ago, we had several reviews that were published and were on the Web of Knowledge most highly cited papers. So that was really pleasing to me to see the success that we've been having with the review articles at Monthly Weather Review.
It seems like review articles are a lot of work, but there's a huge payoff, like you said, in terms of citations and generally what they do for the field and for younger readers, especially grad students, et cetera. I know I'm not a grad student, but I learn a lot, and I learned a lot from these two papers. So I think it probably goes beyond even the graduate student community to pretty much anyone in the field who's had their attention on some other areas, or maybe have been following it and kind of curious to see where the state of the field is. I'm wondering, Dave, in taking on review papers, though, from your perspective as an editor, is it a different kind of beast, so to speak?
Oh, yeah, absolutely. Because I've set this vision for a higher standard for these review articles, that they're going to serve, bigger portion of the community, that people, outside the Monthly Weather Review readership, typical readership, may find these papers useful. So I want them to be high quality. I want them to speak to a larger audience, not just the people who are interested in this particular topic. And so, I have high expectations of these reviews. Of course, not all the ones that have been submitted to Monthly Weather Review, like, regular articles, not all of them survive. For most articles of Monthly Weather Review, they receive 2 or 3 reviews from usually anonymous peer reviewers. For most of the reviews we've done at Monthly Weather Review since I've taken them on board, I've had 4 or 5 or sometimes 6 reviewers. And then I myself will also write comments for the author to help shape the readership of the manuscript, make it more readable, and catch things that I see with the manuscript too, that maybe the reviewers didn't see, or, maybe their focus is more on the science and getting that right, and making sure that all the citations are in there. I'm more interested in oftentimes the readability of it, how it's structured, does it communicate to the right audience?
And I wouldn't, I don't want to sell anything short here at all. I want people to know, Dave, that I've read a lot of your papers over the years, and one of the things you do very well is dig into the literature and find things that people often miss in your review process as you're working on papers. And I'm kind of wondering, I get the feeling that you're often really motivated by the sense of discovery about what's happened in the past and how it shapes and the ideas of today. And so I know you take evident pleasure in this kind of work. I'm also wondering too, Clark and Julia and Kim, maybe you guys could tell us a little bit about what motivated you to get into writing such a comprehensive review paper. And we're talking about 200 references, per paper. There's a lot of groundwork went into this, and that, of course, enriches everything. Where did you get into the idea?
Well, the comments were made a little bit earlier about these reviews serving as great references for graduate students, and that definitely rings true for myself. The first review paper on ET that was written back in 2003 with Sarah Jones as the lead author and published in Weather and Forecasting served as a great reference for me as I started in graduate school in 2004. I had 2 or 3 copies of that paper that I earmarked, wrote over, highlighted, and just used as I conducted my master's and then later my PhD research. And so being able to have an updated reference, focusing in my case on part 1 on the direct impacts and overview of extratropical transition for future students or current students was foremost in my mind. But I think also I have to give a lot of credit to both Julia as well as to John Jackham at McGill University, because the two of them really helped to spearhead this with discussions spanning a couple of different WMO workshops, the International Workshop on Extratropical Transition in 2012, as well as the follow-up International Workshop on Tropical Cyclones in 2014. And perhaps Julia could speak a little bit more to that.
Yes, so as Clark mentioned, the basic idea for these two papers was born at these workshops, in the latest one in 2014. And after that, we reached out to the community to identify the interest of people to contribute to these review papers. Motivated was this also by the fact that there was a kind of peak in ET research, probably about 10 years ago or so, partly also in association with WMO's FORPEX program, which ran from 2004 to 14. And during this time, a lot of research has been conducted in the field of ET since the writing of this first review in 2003. And the community had the impression that it's time now to step back and see where we are at the moment, what we know more about ET than in 2003, but also what are the current open questions and the future challenges that emerged from that. And after these workshops that Clark mentioned, we reached out to the community and organized teleconferences to see if there is interest, and then also to get a community together to work on these papers. And during these teleconferences, we basically decided that there is enough content for two papers, with one focusing on the transitioning cyclone itself, and one focusing on the downstream impacts. And then we identified Clark and Kim as the lead co-authors for the first review paper, and Michael Riemer, Christian Grams, and myself for the second review paper on the downstream impacts of ET.
And I have to say, it was a very easy choice to be willing to take on co-leadership of the first part, having a great co-lead in Kim to help out, and just the community as a whole. The Extratropical transition community is a very close-knit and very collegial community that has worked together to advance our understanding over the course of 15, 20 plus years or so. And so knowing that there were a large number of people who were really invested in contributing and helping to facilitate the writing process and the revision process that followed from it, as well as selfishly, I knew that I would be coming up for tenure a couple of years after the initial discussions of this paper got started. Like, this would be a really good thing to have on my CV as I was going up for tenure, in addition to all of the other benefits to be derived from it. And so having that in the back of my mind, I'm like, this is a good idea to proceed with selfishly, in addition to the unselfish aspects.
I don't have too much to add past what Clark said, but at the first workshop they mentioned in 2012, I was only a couple months out from finishing my dissertation. And so it's interesting to look back and see how far I've come. And I'm really honored to have been a part of this process to help future graduate students, current graduate students, and the broader community have an updated resource, because I too relied a lot on the Jones review from 2003. And I actually found my earmarked printed copy of that paper just an hour ago as I was cleaning up my office before this conversation.
I'm wondering, also from a purely scientific point of view, given that this community is so close-knit, does that make it easier for you to write this paper, or harder? Or these papers, because you're looking at a community that knows each other's work very well and works together quite a bit. I guess the field programs that are involved, everyone's working from the same data sets or a lot of the same models, and there's a lot of overlap. So does that make it harder to reach what you would call a community document, or something that's really a consensus type of resource, or easier?
I think both are true. I think it made it easier because the community, we have our constructive and creative disagreements at times for sure, but being able to have such a large cohort of individuals contributing helped really ensure that it truly was a community perspective on the document. However, from the writing perspective, it made it somewhat challenging to blend 15, 20 different voices, different tones into a cohesive narrative. And that's something that really stood out in our first round of reviews that I think we'll talk about a little bit later on. But Dave and the reviewers sensed that it had to read more of a dissertation literature review in some regards, without as much cohesion or as flow as it could have had. When you have one or two or three people leading the effort, you can get that more readily than you can when you're trying to put 20 people's contributions together and do so in a coherent fashion.
Dave, how important is it to get that kind of flow? I mean, I often feel that review papers are really exhausting unless there's a really strong viewpoint. But in this case, we're talking about a strong viewpoint that's built quite a bit from discussion and community effort, which is a little different than some review papers that I've seen. So, how important is it, and how did the reviewers go at that?
Well, that's interesting that you brought that up. The idea that so much of the community was invested in one or both of these papers meant that finding 5 or 6 reviewers for each one of them, well, I very well couldn't pick co-authors now, could I? And I had to go outside the extratropical transition community a bit to find those reviewers. Now, that's not necessarily a bad thing because, as Clark pointed out, the readability of these papers becomes so much more important. You're not speaking to the specialists anymore who know everything about extratropical transition. You're speaking to people who are knowledgeable, meteorologists, tropical cyclone people, synoptic types, but they would read this collection of citations and they would go, now, why is this interesting? Why are you telling me this? It may be very clear to the authors, but in this case, it wasn't clear to the reviewers. And so pulling out that storyline rather than just paper X did this, paper Y did that, paper Z did this, those make for the various tedious reads that you're probably thinking of. And that's really what I want to avoid when we publish a review article. I want people to go, I read that, and I found that well written and insightful, and there was a good underlining story there.
A universal definition of ET does not exist. It's hard, it's difficult, if not impossible, to find a precise time in which it's actually happened. And so I'm just wondering, what did you learn from this paper, starting right there from the definition? Has that progress been made? We're only talking about 15, 16 years after that Jones et al. Paper. So history moves very quickly in atmospheric science these days. What did you find?
I think we found that it's still pretty challenging to agree upon a definition of what constitutes the completion of extratropical transition. The 2003 paper put forward the cyclone phase space that Bob Hart put together in the early 2000s, and that had become sort of a de facto standard, but not one that was without its limitations. And there's been a lot of research in the past 15 years or so that have highlighted a lot of those limitations. But from both a scientific as well as an operational or a practical standpoint, we found that there's not really anything that works better, that does a whole lot better. And so that led to a recommendation at December's International Workshop on Tropical Cyclones in Honolulu to move forward with that cyclone phase space as the de facto standard for classifying extratropical transition. But I hope that this paper and the synthesis of the related research that we've provided does a good job of highlighting the shortcomings or the limitations of utilizing that method as a black box, so to speak, for classifying extratropical transition. Kim, I don't know if there's anything you'd like to add. I know a lot of the research that has been done to look at other methods came out of the group that you were a part of at Arizona. Is there anything that you'd like to add there?
It's difficult to have a universal definition of ET. There's so many ET flavors. Some of the work I've done showed how they will take different pathways than the expected becoming asymmetric before losing their warm core approach. So we work with what we have, but more work is needed to find something that is more universal by using perhaps more high spatial resolution data sets or other techniques that are still in progress or could be further refined. But the short answer is ET is complicated and difficult.
One of the other things that the Jones et al. Paper mentioned quite a bit was sort of boundary layer conditions were unknown. There's a need for sort of studying real storms and getting real case studies together. And it seems like you're saying that the timing of this paper was made possible by so much work that was done out in the field, not just modeling studies, et cetera, but actually out gathering observations. What were some of the factors that made this paper possible in terms of new knowledge and new observing, new modeling capabilities?
I think focusing on part one, some of the advances tied to the structural evolution, whether that be the expansion and evolution of the wind field associated with the cyclone from the very compact, rather symmetric structures with tropical systems to the more asymmetric and expansive structures that you typically see with extratropical or mid-latitude cyclones, as well as the precipitation distribution, again, going from more symmetric during the tropical phase to more asymmetric during the extratropical phase. And then just a better understanding of the structural evolution as you go from that symmetric system to one that has frontal boundaries associated with it. And there are a lot of observations taken in the Western North Pacific in the 2008 or so timeframe. Perhaps Julia would be able to speak more to those. That really helped deepen our understanding. We've been using as a field those observations and others that have been collected since then over the past 10 plus years to really deepen our understanding of not just of general structural evolution characteristics, frontal development, precipitation, wind field evolution, but also some of the case-to-case variation, although there remains a lot that needs to be done in that regard.
For the field campaign that Clark mentioned, this was the T-Park field experiment. It was in the context of FORPEC's Pacific Asian Regional Campaign in 2008. And it ran for about 2 months, I think. And the main focus was the investigation of tropical cyclones and also their extratropical transition in the Western North Pacific. And there were, I think, 4 or 5 aircrafts involved in this campaign, which flew into 3 or 4 tropical cyclones there and provided a lot of data, in particular on the transitioning cyclone itself and the structural evolution and new types of measurements with water vapor, LiDAR, and so on. So this was a wealth of data that was available after the field campaign. And I think there were other campaigns later which may have also contributed to the data, but I don't have the details for them.
It seems like even with all of this new data, though, a lot of questions come up even within the North Pacific. Like I think you were alluding to the variability, the variations in the cases, and there's still quite a bit to iron out. Is that a fair assessment, Clark?
Yes, I think that's quite the fair assessment. And we highlight some of that in part one with regards to the wind field evolution, whether you have a maximum of winds on the left side of the cyclone as opposed to the more traditional right side of the cyclone when it becomes extratropical. The influence of terrain, especially near Japan, but also the east coast of North America. And then as you get into part two, a lot of the variability from case to case in terms of the downstream development that Julia would be able to comment on.
Yeah, I was fascinated, Julia, but you had a really interesting sort of, I guess I would call it an analogy to music in your paper where you talked about sort of the harmony of the transition with the larger scale sort of wave setup, and that these waves kind of line up or don't line up, and that makes a huge difference in what the downstream impact is going to be. Trying to find that sentence for you, but you may remember it. It was about the positioning of the various features in the atmosphere making such a big difference.
Yeah, you mean the phasing probably between the tropical cyclone and the mid-latitude flow configuration.
Yeah.
Exactly. So this was a feature that was already known at the time of the writing of the first review paper in 2003, that the downstream impact, but also the transition of the cyclone itself, is sensitive on how the transitioning storm lines up with an upstream trough that may be positioned to its west. And since then, substantial progress has been made in further identifying how the tropical cyclone itself influences this phasing, and also the existence of a kind of bifurcation point near the tip of this upstream trough could be identified. And it depends on to which side of this bifurcation point the tropical cyclone is moving, whether it undergoes re-intensification and extratropical transition and lead to a downstream impact, or whether it dissipates without a strong downstream impact.
Yeah, the ET process can be interpreted as a resonant interaction, which and I like not only the resonant part, but the interaction part, in that it seems like the picture is, even though this was known earlier, that the picture is much more complicated, or at least the details can start to be filled in a much more complicated way now. You even mentioned something about that the preconditioning of the atmosphere is a lot more than just the lining up of the disturbances.
Yes, I think one major advancement in knowledge has also been made on the contribution of diabatic processes, which it was clear that they play a role in the amplification, but since this first review paper, it now became more clear that the diabatic outflow of the tropical cyclone in the upper troposphere is really important for amplifying this first downstream ridge, which often is the start of a downstream development. And this, of course, depends on the availability of moisture. And if another weather system has been in the area before and transported tropical moist air into the region where the tropical cyclone is transitioning, this kind of favors the development of ET as well. Yeah, so this preconditioning, as it is called, is a rather recent finding. We touch on it in the paper, but this is also one point where more research might be needed in the future to better understand the processes involved in this and the contribution to the eventual development.
Would it be fair to say that one of the motivations for these papers and for reviewing ET transition is that sort of problem that the complexity of the situation involves not just the motion of the air, but the moisture and the energy that represents, and that until fairly recently, that was extremely difficult to measure and observe in these specific case studies and in fine detail. Like that maybe this is an area that's going to open up, and not only in the measurement and observation from satellites or from various instruments aboard airplanes or otherwise, but also in terms of the models getting to the point where they can represent that better.
Yes, I think the development of the models, on the one hand, on the availability to explicitly resolve convection, but also the increasing availability of high resolution ensemble forecasts really helped to better understand these processes. And in particular for part 2 of the review papers, I would say that this availability and this increasing capabilities of the model played a crucial role in enabling these new findings. And in terms of the motivation for this study, in particular from the European perspective, it is also that we are located downstream of the transitioning hurricanes in the Western North Atlantic. And during this extratropical transition, you can often observe that the predictability in downstream regions is decreased, which means in particular in Europe, we often have a dip in predictability downstream of ET, and thus potential high impact weather that might be associated with ET. It's more challenging to predict for our forecasters.
One of the decisions that was a very positive outcome of the review process, I think, was to lead off part 1 with the description of Sandy and its multifaceted impacts to the mid-Atlantic and northeastern United States, and then inland from there. In that, Sandy really exemplified a lot of the operational and communication challenges associated with these transitioning structures from tropical cyclones, where you tend to look over a pretty narrow area near the center, to non-tropical cyclones that people tend to think are weaker, but aren't always weaker, but are often more expansive with their impacts, both in terms of wind, but also in terms of precipitation as well as wave action. And here in the United States, at least, we didn't really have a good system to be able to handle that transition when you're looking at a case so near to land as Sandy was in 2012. I think that that case does a really good job of highlighting not just the structural changes, but the issues with predicting it and communicating it. And I think later on in the paper, we really discuss the predictability of the structural evolution itself, the direct impacts. And one of the things that came out of that, at least for me, was that there's just not been that much that has been done research-wise to quantify how well we can predict that direct impact of tropical systems during extratropical transition. Most of the papers we ended up citing are about 10 years old, and there have been dramatic advances in model development and model skill since then. And you see that come across, I think, to some extent in part 2 with the downstream development, although that still is a challenging problem intrinsically to forecast. But we really need to go back and look at that from the direct impact standpoint with modern state-of-the-art modeling systems to be able to better understand just how well we can predict those impacts, even if we can get the track right, even if we can get the overall intensity right, like we did with Sandy. How well can we get the impact right, and how well can we communicate that to a public that doesn't know as much about this process as we might hope that they would?
Communicating the impacts from a tropical cyclone and an extratropical cyclone are fairly similar as far as some of the challenges, because people want to know where they are. Will they get strong winds? Will they have to deal with strong, heavy rainfall? How long will they have to experience those heavy rains, those strong winds? And there's a lot of association placed with a system that has a name. So in a tropical cyclone situation, it's named, and the National Hurricane Center is advising on it. And we have products that they are continuously improving to talk about things like timing and duration. And I think we can learn a lot from that in communicating the impacts from a storm that has undergone or is undergoing extratropical transition. But as seen with Sandy, there is a challenge in who is going to give that information and when any handoff should occur. If a storm loses its name, so to speak, people pay less attention to it. Similarly to how many people take a threat of a tropical cyclone less seriously if it goes from a category 4 to a category 2, even though the system itself is expanding both its wind field, the extent of its precipitation, and here I'm referring to Hurricane Florence from 2018. What we're doing for tropical cyclones has merit for how we could communicate extratropical cyclone impacts, especially since some of them are similar, such as winds and storm surge, even though we are entering areas much less frequently affected by tropical cyclones. So if we can take advantage of what we learn from what the National Hurricane Center and others are advancing for extratropical transition, I think we have a good chance of improving that communication, but it does rely on strong, accurate, understandable forecasts of those direct impacts, as Clark mentioned.
And it seems also that once the transition is underway, changes in the storm mean that the impacts are going to be a little different, or the forecaster also has to look at it a little differently because, for instance, we were talking about the expansion of the wind field, so that it looks to me like, the peak is still there close to the center, but there's a lot wider spread of high winds in the distribution of the winds. And also this question of whether the right side or the left side poses a greater threat for winds. And then the addition of the winds being an important force in terms of determining what the waves are going to be. So, Kim, when you say the lessons of communications apply both ways, I think that makes a lot of sense, both for people who are doing the tropical warnings and whoever's going to be doing the extratropical warnings. But it sounds also like they should be reading these papers to understand the differences in terms of the subtle ways in which the threats could be greater or less or in different areas because the storm has evolved.
The better those issuing the forecasts understand the nuances, ideally the more effective their communication will be when they get improved tools to issue those advisories or those warnings.
Julia, would you say that the warnings and forecasting issues are similar or a little different from your viewpoint in Europe?
I think for us, the forecasting issues are a bit different because often we don't get the actual extratropical cyclone coming all across the Atlantic to Europe, but we rather get the cyclones that might develop downstream as regular extratropical cyclones. And for them, of course, it's the same challenge for our forecasters than normal extratropical cyclones that develop, for example, during the winter season. But often it's not real. So we often have an uncertainty associated with how the track of the storm will be due to the different probabilities on how the Rossby wave pattern will develop due to ET, and how strong the Rossby wave packet will amplify, and thus also how strong these cyclones may become.
You also had in your paper, though, an example from, was it Typhoon Nuri in 2014, where again, it's sort of this way downstream impact.
Yes. So Nuri was one of the major typhoons in that season, and it had a huge impact also on North America, because I think the storm itself tracked nearly close to Alaska, and it was associated with a huge ridge amplification over the western North American coast, and of course a trough then over the eastern part. And that also was associated with a heat wave in California and other high impact event features. So that's kind of the same what we experience in Europe. Although the Rossby wave packets that develop over the Atlantic during or after an ET, they are slightly different than the ones in the western North Pacific. It's still not fully understood on why this is the case. We assume that it has to do with Rossby wave breaking in course of ET, but it's also one of the open questions that remained after our paper and are mentioned in there as a future research need.
So these papers, research needs, of course, review papers, what I would hazard to say, what do you see as the big research needs coming out of this paper? And are any of them a surprise to you now that you've done all this research?
For part 2, I would say that we realized it was kind of clear to us, but some of the findings are still mainly based on case studies. So we have a rough understanding on what's going on, but it needs a more quantitative assessment, or also more from a climatological perspective, to understand, for example, the impact of ET on the downstream evolution of high impact weather, or also the preconditioning, what we mentioned before, is another factor that is of interest, which needs another perspective than only the case study perspective.
Tim, any surprises for you in terms of where this set of papers is leading?
I feel like one thing that was surprising to me was we have a lot of observational data, but we could use so much more. Somehow, as with a lot of science, what we observe leads to more questions. And so we need observations to help us answer those additional questions.
How about you, Clark?
I think one of the things that stood out to me in preparing part 1 was just how little has been done in terms of the wave impact and the wave evolution associated with transitioning cyclones. It's difficult to get observations there at the atmosphere-ocean interface during these intense events. One of my professors always used to joke that that's the job of graduate students, but I don't think it's that easy to put graduate students out there on boats in the central Atlantic and gather the measurements we might need to be able to help our understanding. And so there's just been little that's been done to understand how the wave field evolves, and in particular, activities on the wave-ocean interface, like wave breaking, sea foam, things of that nature. And so there's still quite a bit that one could do, and I hope that the paper motivates that sort of research wherever it may come. Certainly the wind field will have a direct contribution to that, but there likely are other nonlinear processes at play too.
I like the fact that we've now hit wave breaking from two different perspectives, the breaking of Rossby waves high in the atmosphere and wave breaking right on the surface of the ocean. And I think that kind of encapsulates the breadth of these papers, from defining what extratropical transition is all the way to the implications in terms of communications in forecasts and warnings. And I guess that impressive breadth gets us back to that question about how do you review papers like this. And Dave, I'm wondering, what kinds of surprises did you see in the papers as they evolved, and how also did you handle that problem of reviewing such a broad range of issues?
Yeah, that's a good question, Jeff, because as chief editor, anytime a manuscript that's been submitted to our journal appears in my inbox and it says part 1 at the end of the title, that's that starts a whole chain of thinking in my head, like, oh no, now there's going to be a part 2. Will there be a part 3? Even if there's only 2 parts, are they coming at the same time, or will they be spaced out? Will I have to get the same set of reviewers for part 1 and part 2? If these are review articles, then naturally they may be longer than a normal article. What kind of reviewer is going to want to review these manuscripts and invest that much time in them? So it's always one of those things where I start to go, all right, now I've got to up my game and rise to this challenge. And sure, the breadth of material inside just one of these articles, let alone both of them together, did make it a challenge. But as I said before, this is one of the reasons why I like having a large number of reviewers for these manuscripts, in part because I want these to be respected. I want them to represent a community consensus as much as that is possible. And so having a large number of reviewers will give me more feedback than a normal review process. But having a large number of reviewers will also allow me to pick and choose the different material. So, people who have tropical cyclone expertise can bring that to bear. People who have extratropical cyclone expertise can bring that to bear. People who have, air surface, or air sea flux expertise can bring that, and jet stream expertise, and, precipitation and cloud microphysics. All these different aspects are entailed in these review articles to some degree. Having all the discipline specific, let alone observational, modeling, theory, practical, operational forecasting, all of those elements have to be entwined as well. So you see rapidly why having breadth on the team who did the reviews, and I really want to thank those people for dedicating their time. They know who they are.
Yeah, we can definitely give a shout out to the reviewers. That's quite a task, and I like to think that what you're saying in a way is that by doing that, by making sure that so many good eyes that were willing to stretch, so to speak, to review these papers were on the papers during the review process, that you've got something that will withstand the test of time. I think that's something that's been a hallmark of Monthly Weather Review for, what is it, 148 years now, or 147?
Yeah, we're pushing it. It's great. Yeah, almost 150.
It's pretty incredible. But unfortunately, given where we are with atmospheric science moving ahead so fast, so it took 15 years to get to the review, to redo the review papers. So let's project maybe in 7 years, you're going to need another review paper on this topic. And in the meantime, you're going to have had a lot of other studies and review papers to fill in the gaps in other areas.
Well, let's be frank. Oftentimes review articles get written, and it kind of summarizes an interesting period of time in atmospheric science where someone felt the need to write these. It's not very often that review articles get updated, and in this case, certainly so frequently as just 15 years or so between the papers. So I think that makes it extra special, and I think it also indicates, as people have mentioned before, how quickly the discipline has grown.
I want to thank you, Dave, for being a part of this and helping me host this, bringing together these wonderful authors and two amazing papers. And also thank you, Clark and Julia and Kim, for writing papers and for being on the podcast.
Thanks for listening to this episode of AMS on the Air. If you want to hear more episodes, subscribe to the feed that you're listening to now, or if you're listening on our website, just come back in a week or two and we'll have a new episode up. Follow us on Twitter, Facebook, and Instagram. Just find us at AMS on the Air. And finally, if you can, give us a rating or a review. We'd love to hear from you. And if you have an article or a review paper you'd like to submit to the Monthly Weather Review, visit ametsoc.org/submit. That's ametsoc.org/submit. See you next time on the air. Happy weather.